Today we will be exploring one of the most interesting concepts in the of artificial intelligence, agentic AI and AI agents. We are in the middle of a major shift in the history of artificial intelligence. AI research and development is evolving from relatively simple AI that follows strict instructions given to it by humans to AI that exhibits characteristics of autonomy and independent decision-making. After today, you should better understand, what is agentic AI? What characteristics define an AI agent? How the work of AI agents differs from traditional artificial intelligence. Examples of applications. The limitations of applying agentic AI. And where research is headed in the future. Let's begin. So what is agentic AI? Essentially, agentic AI refers to independent AI, or AI with a certain degree of autonomy. In other words, you don't have to give the AI very specific instructions about what to do. Instead, you can give it a general idea about what to accomplish, and it will use autonomy or agency in figuring out how to accomplish the task. Think of it as an employee. You might tell a human employee what to accomplish, and they have to use their initiative and judgment in figuring out how to complete the task. Some key characteristics of agentic AI include autonomy. These systems operate independently, making decisions without consent human guidance. Goal orientation. They work towards specific objectives, not just respond to immediate inputs. Perception or awareness. They can sense and understand their environment, whether that's digital data or physical sensors. Adaptability or learning. They learn from experience and adjust their strategies based on feedback and outcomes. And agency. They have the capacity to influence their environment and take meaningful action. Note that not all agentic AI is equal, however. There is a spectrum. Some AI requires a greater degree of human intervention than others. So, we can say there are varying levels of autonomy. Understanding AI agents. So let's now talk about what defines an AI agent. First of all, note that in the academic literature, an AI agent is often defined as an entity that demonstrates perception and action, or takes action, based on what it perceives. This is a slightly more technical way of saying what we just said above. Let's unpack this definition. Perception or awareness refers to information coming in via sensors. That could mean things such as cameras for a robotic vacuum or natural language processing for a customer service chatbot. Then, cognition refers to using that information to make decisions. And then, finally, action, executing those decisions. That could be moving a robotic vacuum around a room or a chatbot replying to a customer. Finally, note that many agentic AI have feedback loops. They use the results of their actions to update their decision-making processes. So, what are the different types of AI agents? Let's first classify agents according to their level of reactivity, how they react to the environment. Reactive agents operate based on the simplest form of decision-making. Deliberative agents perform reasoned actions. Hybrid agents combine aspects of both. Other distinctions include simple reflex agents, minimal logic, follow predetermined rules. Example, email spam filters. Model-based agents maintain an internal model of the world. Example, autonomous vehicles that model road conditions, traffic, and obstacles. Goal-based agents work actively to achieve specified goals. Example, route planning algorithms. Utility-based agents make decisions that maximize a utility function or objective measure. Example, portfolio optimization algorithms in finance. By operating environment, single-agent systems, one agent operating independently. Multi-agent systems, multiple agents that may cooperate, compete, or coexist. This adds layers of complexity as agents must consider each other's actions and goals. From traditional to agentic AI. What is the difference between traditional AI and agentic AI, exactly? Let's examine what classical or traditional AI is first. Traditional AI is usually rule-based, and it often relies on methods such as supervised learning. Traditional AI can take many forms. It can be something as simple as an email spam filter, or it can be a complex system such as a self-driving car. Rule-based expert systems were common in the past, and they involve programming specific rules into an AI so that it could mimic the decision-making of a human expert. Agentic AI addresses many of these limitations. Agentic AI learns from experience, including from its mistakes. It has more flexibility and autonomy, and it can operate in more complex domains. It can pursue multiple goals. You can see difference in traditional and agentic AI in highlighted. Also attached some of examples of both which they performed. The key limitations of traditional AI are lack of flexibility and adaptability in many cases. Need for extensive human input. Challenges dealing with uncertainty and ambiguity. Often working with relatively simple tasks or environments. Let me give you some examples of traditional and agentic AI. An example of traditional AI is an image classifier. A traditional image classifier might be able to recognize cat pictures with a high degree of accuracy. However, it would not be able to recognize a drawing of a cat as a cat. It would see it as something else. An agentic AI, on the other hand, could recognize a drawing of a cat as a cat. It would also be able to adapt its parameters so that similar images are recognized correctly in the future. Another example of agentic AI is an autonomous robot that delivers packages. The robot will learn the shortest and most efficient routes, as well as adapting to various obstacles and the preferences of different customers. Let's now examine the architecture of agentic AI. Note that different sources can present it slightly differently. Here's one version. Typically, an agent architecture can be broadly divided into several parts. Perception, input. Perception refers to input or information coming into the AI agent. This could be visual information from cameras, verbal information from conversations, or it could be information received via an API or a database. The information may also need to be processed. For example, natural language needs to be parsed. Knowledge base. Knowledge base refers to the information that the AI agent knows. This might be facts, rules, the outcomes of previous decisions, etc. Reasoning or cognitive component. The decision-making process usually involves planning, reasoning, and learning. In more complex agents, multiple decision-making methods can be used. Planning refers to figuring out what to do, reasoning refers to using logical or probabilistic methods to understand the world, and learning refers to updating information in the knowledge base. The ability to take action or execute decisions. Finally, an agent has actuators, mechanisms that let it actually perform actions in the world. For an AI agent, this could mean sending emails or texts, modifying databases, controlling machinery, etc. A feedback loop. Feedback loop refers to evaluating actions and their outcomes, updating the knowledge base, and thus continuously learning and improving. There are several types of reasoning that can be used in agentic AI. Some researchers separate out symbolic reasoning, probabilistic reasoning, and neural network-based or hybrid reasoning. Symbolic reasoning refers to methods such as classical logic or first-order logic. It tends to be relatively straightforward and transparent but often lacks flexibility. Probabilistic reasoning uses probability theory and can be useful in situations involving uncertainty. Neural networks allow for a different type of reasoning, one that is often quite deep and that can be applied to a variety of tasks, from language understanding to planning. The downside is that it can sometimes be black boxy. It can be difficult to discern why a particular decision was reached. Hybrid architectures often employ multiple types of reasoning. Let's now turn to practical implications. Self-driving cars and robotics. Self-driving cars are arguably the most sophisticated agentic system that has been built to date. These are complex systems that rely on a combination of perception, planning, learning, and acting. They can sense their environment, navigate roads and avoid obstacles, and learn from experience. Robots can serve a variety of purposes: manufacturing robots, warehouse robots, and surgical robots, medical diagnosis and healthcare. There are many medical applications of agentic AI, including diagnosis, monitoring, and treatment. Medical agents can analyze information about patients and learn from experience. Financial trading and investing. There are agents that can monitor financial markets and make trades. These agents can operate fully autonomously or be subject to human oversight. Customer service. Customer service chatbots can help answer customer requests. More sophisticated ones can engage in complex dialogues and have access to external databases in order to actually solve problems. This is another area where human oversight may be necessary. Supply chain management. There are many applications of agentic AI in the supply chain, from monitoring inventories to managing shipments and managing relationships with suppliers. Scientific exploration. Agentic AI can be used in scientific discovery, testing hypotheses, designing experiments, examining data, etc. This can accelerate the process of scientific discovery. Content creation. Agentic AI can create content, not just text but video, and it can update and modify it. Let's look at an example of how agentic AI can be applied in one specific sector. Let's imagine a warehouse that employs autonomous mobile robots. The goal is to make picking and packing of goods as efficient as possible. Let's examine the characteristics of such an agentic system. Perception. Robots scan barcodes and keep track of inventory in real time. Knowledge. Knowledge of inventory, routes. Planning. Planning the most efficient routes. Learning. Learning from experience about which routes are the most efficient. Adaptation. If a certain inventory is depleted, planning different routes. Collaboration. Collaborating with other robots to avoid collisions. These systems enable picking and packing to be much more efficient than with human workers or traditional warehouse systems. Such systems allow for high-volume operations with fewer personnel. They can adapt to seasonal variations in demand. And they can reduce accidents. Let's talk about the future of agentic AI. What do you think the future holds? I have some thoughts on this. Increased autonomy. We will see a lot of the agents from the future to be able to operate autonomously with minimum or no human supervision at all. These agents will be able to address more complex problems, operate in more diverse environments, and require human supervision only in special circumstances. They will also be able to create and use sub-agents to delegate tasks. Improved reasoning and planning. The future agents will be able to reason and plan much better than their current counterparts. These agents will be capable of more human-like reasoning, using common sense, addressing ethical dilemmas, and planning long-term goals. Better safety and alignment. The future will see the birth of much safer and more aligned agents with built-in safety mechanisms, interpretability, controllability, verifiability, and formal guarantees of safe operation. Embodied AI. We will see a rise of embodied AI in the future, where AI agents take physical form as humanoid robots. These agents will operate in a physical world while being connected to the digital world. Collective intelligence. We will see agents working together in collective intelligence systems to solve more complex problems than any single agent could handle alone. Personalization. The future agents will be much more personalized, learning about individuals and serving their specific needs over extended periods of time. Let's summarize everything we have discussed today by highlighting some key takeaways. Agentic AI is a type of autonomous AI system that operates on its own to achieve specific goals, with minimal human input. This is fundamentally different from the current crop of AI agents, which are mostly activated by specific prompts and then terminate. Agentic AI is important because of the following reasons. It enables truly autonomous operation of many important systems. It enables solving much more complex and difficult problems than ever before. It reduces the need for human supervision of AI systems. It enables agents to adapt themselves to new challenges. Agentic AI is already starting to have an impact, though most of the current implementations are limited to specific domains. Looking to the future, agentic AI systems are set to become much more capable, autonomous, and general purpose. For practitioners, think about solving real-world problems, start with hybrid approaches, make your agents safe, make use of human oversight, and realize that you will need to continuously update and improve your agents. Thank you for watching this video. Please like, subscribe this channel.